let's continue our discussion on integration by substitution. So, for example number 5, again, this is a composite function. I can tell it's composite because I have an inside function here. So when I rewrite this one, I can keep the x right there, but I'm going to bring this up. I'm going to do this all in one step here. We're really good at this. This is 3x squared plus 4 to the negative a half dx. So once I do it this way, it doesn't look so bad. For U substitution, U is going to be the inside part, so U is going to be this 3x squared plus 4. Taking the derivative, remember, that's going to replace this one. The du, to replace dx, I got to take the derivative with respect to x. That gives me 6x dx, which is just dx is du over 6x. 6x, we got it. We're going to replace now. When I replace this, the x stays here. This is being replaced with u to the negative 1/2, and I got this du over 6x. Now remember, the goal is to either replace all the x's. We're either going to, 1, replace x's, or 2, cancel all the x's. In other words, we don't want any x's left in the problem. Those x's cancel, so in luck, this 1/6, I can bring it to the forefront, make it look a little bit easier for us. This is 1/6 u to the negative a half du. We haven't taken the antiderivative yet, but now we're ready to. So that's why we still have this integrand and that du. Don't forget those. Those don't go away until after we take the antiderivative. Integrating, we get 1/6 u. Add 1 to here, we get 1/2, and this becomes 2 over 1, plus your constant of integration. And we can rewrite it. You can write this as 1/3 if you like. U, which is this 3x squared plus 4 to the 1/2 plus c1. Don't forget to replace u in the end. I'm going to replace u. Number 6, let's try this one. If I would rewrite it, we would get this x plus 1. And here, I'm going to bring this up. This becomes x squared plus 2x to the negative 3, because, again, I'm bringing it up. Well, this is, again, a composite function, so it looks like I have 2 insides. So which one should be u? Well, obviously, the more difficult one. So I'm going to let u equal this x squared plus 2x. That's going to replace this part, and now I got to replace that dx by taking the derivative of u with respect to x. I get 2x plus 2 dx. And I get dx equals du over 2x plus 2. So replacing it, we get x plus 1. This is just u to the negative 3, and the dx we just said is du over 2x plus 2, right here. Now, look at these. They don't look like they cancel, do they, right now? Man, right now it doesn't look like I can actually answer this question because it doesn't look like these cancel, so I have to get creative. I can factor out a 2 here, and I get 2 times x plus 1. And now those x plus 1's cancel. All my x's are gone. I'm just left with u. Just like a relationship. All my x's are gone. I'm left with u. So this becomes u to the negative 3 du over 2. I still have that 2 there. I'm going to clean that up a little bit more, make that 1/2 u to the negative 3 du, just to make it look prettier. Now I can integrate. Now I haven't taken any antiderivative. I haven't done any calculus yet. I've just done some algebra stuff. But now I can take the antiderivative. We get 1/2. This becomes u to the negative 2, because we're adding 1, over negative 2 plus c1. Finally, not a fraction. We have to invert and multiply, right? Rewriting it, this becomes negative 1 over 4 u squared plus c1. I put the negative exponent on bottom. We don't like that negative exponent. Replace u, 1 over 4. U, we said, was this x squared plus 2x plus c1. And there is our antiderivative there. That's a pretty nasty one right there. That's probably about as bad as they get right there. All right. So that's U substitution. So now people always think, man, everything is U substitution. And the answer is no. No. The answer is not everything's U substitution. Even though this looks like it's a composite function, there's no power here. So for something like this, I can just distribute. And that's just going to give me 3x squared minus 4x dx. And this one's not that bad to do. I get x cubed, adding the 1, minus, this becomes 2x squared plus c1. You can check your power rule on that one. This is just a power rule. What about something like this? I could use U substitution, but it's going to be kind of pointless. But if I rewrite it as 1/2, bring the square root of x up. X to the negative 1/2 dx. And again, just power rule. 1/2 x to the 1/2 times 2 over 1 plus c1. So that's just x to the 1/2 plus c1. There we go. I don't have to use, not everything is U substitution just because it looks composite. Let's take a look at number 3. For number 3, this is the one we want to split it. I could write this as x over x to the 1/2 plus 2x squared over x to the 1/2. And this just becomes x to the 1/2 if I do my algebra rules. And this becomes plus 2x, 2 minus 1/2 is 1/2 or 3/2 dx. And again, I can just use my power rule here. This becomes x to the 3/2 times 2/3 plus 2. This becomes x to the add 1, 5/2 times 2/5 plus c1. An easy way to tell if you really have to do U substitution is if there's something other than x on the inside. So a nice hint for U sub only if something else is on the inside. Only if x is not alone on the inside. In other words, something at the square root of 3 plus x, U sub. Something like the square root of x, not U sub. Because the x here is alone, and the x here is not alone. All right. I'm going to do this one. This is actually part of tomorrow's lesson, but it's kind of a fun one to do. This is what we call algebraic substitution. I'm going to rewrite this just like we would. This is just 2x minus 1 to the 1/2 dx. I'm going to do my U sub just like I would normally. My U would be this 2x minus 1. My du would be 2 dx. So give me dx is du over 2. Now if I write this, I'm going to get x u to the 1/2 du over 2. Now here's the problem. Notice the x's don't cancel. Don't panic. If the x's don't cancel, it's going to be okay. If the x's don't cancel, it's fine. We still can't integrate it because I got to replace this now. We got to find out how to replace this x since it didn't cancel. So to do that, we do something called an algebraic substitution. And all that says is, look, man, I know u is 2x minus 1. What if I solve for x? I would get u plus 1 over 2. And now I could rewrite this as my x is u plus 1 over 2 times u to the 1/2 du over 2. See, I just replaced it with this. I just substituted. Whoa, sorry about that. Ah, the madness. Sorry, my foot just ran into the cable. Hope you're okay. That was very traumatic for me. All right, so I was just able to replace my x using my substitution. And now I can simplify this a little bit. This becomes 1/4. And if I distribute the u to the 1/2, we get u to the 3/2 plus u to the 1/2 du. And now to get my final answer, if I were to integrate that, we would get 1/4. This becomes, now we're going to use our power rule, u to the 5/2 times 2/5 plus, add 1 here, u to the 3/2 times 2/3 plus c1. And the last thing we got to do, that's right, replace u. So we get 1/4, 2/5, plug your u back in, 2x minus 1 to the 5/2 minus 2/3, 2x minus 1 to the 3/2 plus c1. And there's your answer. Do not simplify that, man. Just leave it alone. Okay? Just leave that one alone. Okay? All right, I hope you guys enjoyed the video. I'll see you all later. Bye-bye.